Hi everybody, I'm Jacob Leong. Today I want to discuss subtopic 1.2 inverse variation from chapter 1 variation. The first learning standard for today is explain the meaning of inverse variation. What is inverse variation? The variable y increases when the variable x decreases at the same rate and vice versa. Okay, that means if y increase, x will be decrease, or when y decrease, x will increase. So the relation can be written as y varies inversely as x. This is an example about the relation between y and x for the inverse variation. Okay, so we look at this table. The table shows the time 4 hours, 5 hours, 6 hours, 7 hours, and 8 hours, and average speed is 10.5 for 4 hours, and so on. Qiamin take part in a 42-kilometer marathon. Okay, so we look at the question. State the change in average speed if the time taken. Okay, now we look at the time taken. If the time taken is increases by 2 times or decreases by 1.5 times. So we look at the solution. Okay, now we look at the time. Okay, let's say time in the beginning is 4 hours. Okay, increases by 2 times. So 4 times 2 we get 8. Okay, we get 8. After that, V at the starting is 10.50 km per hour. Okay, after that, if time is increased by 2, that means average speed is decreased by 2. Okay, so 10.5 should be divided by 2, you get 5.25. So what's your conclusion? You can do the conclusion like this. When the time increases by 2 times, then the average speed will decreases by 2 times also. Okay, so that means one increase, another one is decreased. Now we look at B. Okay, B, the time taken is decreases by 1.5 times. So the time at here, let's say, okay, I take 6 hours. 6 divided by 1.5. 6 divided by 1.5, that equal to 4. If the time here decrease, that means the average speed will be increased. If the time decrease 1.5 hours, that means average speed will increase 1.5. Okay, so your conclusion can be like this. When the time decreases 1.5 times, then the average speed increases by 1.5 times. That means when y is decreased, x will be increased. Okay, for this slide is self-practice. You can try to do these 2 questions according to the relation between y and x for the inverse variation. For second learning standard is determine the relation between 2 variables for an inverse variation. So we look at this table. Okay, the first column is statement, and then second variation, relation, and then equation form. K as the constant of variation. Okay, the first one, y varies inversely as s. Okay, if you write in variation relation form, you can write like this. Okay, by using this symbol. Okay, variation relation, and then if the variation relation change to equation form, okay, so you have to write y equal to k over x. Okay, okay. Second, y varies inversely as the square of x. So for variation relation, you have to write like this: y varies to 1 over x squared. Here is 1 over because of inverse, so 1 over, okay? So if you change to equation form, okay, you can write y equal to k over x squared. Okay. After that, number 3, m varies inversely as the cube of n. Your relation, you write like this. Okay, m varies inversely. Okay, so you write 1 over n cube here. After that, if write to equation form, m equal to k over n cube. So you have to compare the differences between variation relation and equation form. Number 4, also same. P varies inversely as the square root of Q. So in variation relation, you write like this. Okay, the symbol, this one varies inversely. So inversely, you write 1 over square root of Q. Okay, after you change to equation form, becomes P equal to K over square root of Q. And then number 5, E varies inversely as the cube root of F. Variation relation like this. E varies inversely. Okay, so inversely, that means 1 over cube root of F. And then for equation form, E equal to K over cube root of F. Okay, look at the first graph. The graph of y against x is a hyperbola. Okay, this one, the shape of this graph is hyperbola. Okay, and then this one, the graph of y against 1 over x. This one is a straight line. Okay, that start from the origin. X is not equal to 0. So this one, y against x. This graph is y against x. And then this one is y against 1 over x. This one is hyperbola shape. This one is a straight line. Okay, look at the example below. It's given that the time needed t to assemble a piece of furniture varies inversely as the number of workers x. The table below shows the relation between x and t. Okay, x represent the number of workers. Okay, 2 workers, 3, 4, 5, and 6. Times needed in minutes, 180, 120, and so on. By calculating the values of xt and x squared t, determine whether t varies inversely as x or x squared. After that, you have to write the relation, okay, by using this symbol. Okay, we look at the solution. X and t, I copy down all the values of x and t to inside this, okay, inside this column. After that, the first one is xt, that means x times t. X times t, 2 times 180, 3 times 120, and so on. Okay, and then without that, we get the same answer for all the columns. Okay, and then how about x squared t? X squared t means 2 squared times 180, and then 3 squared times 180, and then so on. Okay, and then without that, from here, we get different answer from all the columns. Okay, what is the conclusion for this? Okay, from here, we found that xt is a constant, but x squared t is not a constant. So you can make conclusion t varies inversely as x. After that, you can write the variation relation like this. Okay, this is your variation relation. T varies inversely as x. Okay, this one inversely, that means 1 over x. Another example, 2 quantities x and y vary based on the table on the right. By using a suitable scale, draw the graph. Okay, they ask you use suitable scale. Draw the graph of y against 1 over x and show that y varies inversely as x. So we look at the solution from the table. Okay, this one is the original value. Okay, y against 1 over x. So that means your x must change to 1 over x. 1 over x, also you calculate like this. From here, x is 2. 1 over x means 1 divided by 2, you get 0.5. And then second column is 4. So 1 divided by 4, you get 0.25. And then third column, 5. 1 divided by 5, you get 0.2. And then the last one, 1 over 10. 1 divided by 10, you get 0.1. And then y, this one remains same. So y, you just copy down the value of y from here. Okay. After you get a new table, you can start to draw the graph. Okay. This one, okay. This one they use you have to use the table scale. They use 1 cm to 0.1 on the x-axis and 1 cm to 2 on the y-axis. Okay, after that you will get a straight line. Okay, for this example, it's given that x equal to 0.25 and y equal to 3. Express y in terms of x if a, y varies inversely as x, and then b, y varies inversely as the square root of x. So we look at the solution. Okay, first step you should do is you have to write the variation relation followed by according to the question. Okay, y varies inversely, so that means this one 1 over x here. After that, you have to change your variation relation to equation form. So when you write equation form, your k should be on the numerator. Okay, numerator is k. Okay, y equal to k over x. After you write the equation, you have to substitute all the given values onto the equation. So x equal to 0.25, put here, and then y equal to 3, substitute onto here, multiply, you will get the answer for k. The value of k is 0.75. So you have to write your equation back. Okay, your equation should be y equal to k, you change to 0.75. So your equation is y equal to 0.75 over x. Okay. After that, we look at b. Okay, the first step also same. You have to write variation relation. Okay, so this one, y varies inversely. Inversely, that means 1 over. After that, here, square root of x. Okay, follow the instruction. After that, you have to change your variation relation to equation form. Okay, this one is your equation form. Always remember, k always is numerator. K should be on numerator. Okay, so y equal to k over square root of x. After that, you substitute the given values onto the equation. After you substitute x 0.25, so that means this one here is 0.25 square root, and then here is 3. Okay, multiply, you get the answer 1.5. After that, you write the equation. Your equation should be y equal to 1.5 over square root of x. Okay, this is another example. The force of gravity F varies inversely as the square of the distance between two objects D. So this is the first information. After that, this is the given value. So now we look at the solution step by step. Okay, the first one. F varies inversely. So I write like this. F varies inversely. Inversely, that means 1 over square of the distance. Distance, use letter D. So D square here. After you write the variation relation, you have to change the variation relation to equation form. So this is our equation form. Always remember K is on numerator, okay? So F equal to K over D squared. This one is equation form, okay? After that, we look at the second sentence. It's given that the force gravity between two objects is 15 Newton and when the distance between them is 1.2 cm. So F should be 15. Okay, substitute inside here. And then distance 1.2 cm for D, 1.2 square. After that, multiply, you get 21.2 for value of K. After you get the value of K, you get the value of constant. So you have to write the equation. Express F in terms of D. That means equation of F. So F equal to, okay, K change to 21.6 over D squared. One more example for this part. Calculate, okay, if I give you a table like this and then I just write Y varies inversely as X, so you have to calculate the value of S and the value of T, okay? Okay, what's the solution? The first step, always same, you have to write the variation relation first. This one is Y varies inversely as X, so that means 1 over X here. After that, you have to change the variation relation to equation form. Equation form, that means Y equal to K over X. K always be numerator. This one is numerator, okay? So after that, we look at this table. We have 3 columns, right? 3 columns, okay? The first column, xy, x3, y2. Second column, we don't know the value of x. The third column, we don't know the value of y. Of course, we have to use the first column to find K. We cannot use the second column, we cannot use third column because we don't know value of x for second column and then we don't know the value of y for third column. But we have value of x and y for the first column. So you use the first column first. Okay, y2, x3, so you can find the value of K, right? So after you get K, you write the equation form in the complete form, okay? That means y equal to 6 over x, K equal to 6 here, okay? For second step, we find the value of s. So when x equal to s, y equal to 1.5. So I write the equation from here, bring up here. After that, y 1.5, follow the table here, 1.5. But x we don't know, x we write s here. Okay, after that, okay, this one go up, multiply. After this one go down, divide, you get the value of s is 4. And then the last step, we find t, right? Okay, also same, you write the equation back here. After that, x equal to 5. The last column, x equal to 5 here. 6 divided by 5. Okay, y is t, right? You look at here, y is t. So t equal to 6 divided by 5. T equal to 1.2. Okay, this part is self-practice. I give you 4 questions here. Okay, I hope you try your best to do it. Okay, the third learning standard is solve problems involving inverse variation. For example, the number of oscillations A of a simple pendulum varies inversely as the square root of the length of the pendulum PCM in a fixed period. Given that the number of oscillations is 9 when the length of the pendulum is 36 centimeter. Calculate the length of the simple pendulum if the number of oscillations is 15. Okay, now we look at the solution. Okay, the first step, of course, we have to form variation relation. Okay, so A varies inversely as the square root of the length. Okay, P. So this one varies inversely A, and then the length should, is P, right? So you just write inversely is 1 over, and then the square root of length. That means the square root of P here. So you put like this. After you write the variation relation, you have to change the variation relation to equation form. So equation form should be like this. A equal to K over square root, okay, square root of P. K always at numerator, okay? A equal to K over square root of P. Okay, next step, we have to substitute the value inside. Okay, we look at the second sentence. The number of number of oscillation represent A. So A equal to 9. And then length of the pendulum. Length is P. So P equal to is 36. This one, 36. So you just substitute inside here, and then you calculate, you get 54 for value of K. So you write the equation. A equal to 54 over P square root. Okay, like this. This one K change to 54. So your equation like this. After that, how about the third information? The third information, they give you the length of simple pendulum. Calculate the length. Okay, that means calculate P. When the number of oscillation is 15. That means they give you A equal to 15 here. So the third step is A equal to 15. And then K is 54. Now we find the value of P, right? Okay, this one move up, this one move down, get divide, you get 3.6 square root, move to the right hand side, square. So the length of the pendulum is 12.96 centimeter. If you read the question properly, actually this type of question very simple. This one is solving problems question, but still very simple if you read the question properly. Okay, this part is the last self-practice, and then I give you 2 questions to you can try yourself this one. Okay, that is all about the lesson for today. Hope you can understand it well, and then try your best for all the practice. That's all. Bye bye.